Next up, folks, we're going to be graphing f of x equals tangent of x. This is part of our series on graphing trig functions by hand. We're going to go and use the same steps that we did in the previous example. So let's read step 1 together. It says to draw the chart using the same x values. Do you remember from example 1 where we graphed sine what those values are? Give you a second to think, and then we'll go ahead and look at the chart. So before we do that, again, I want to go back to this visual. We're going to start at negative pi and move counterclockwise in increments of pi over 4 and go all the way back to pi. So if you count that, I believe that's 9 values, 2, 3, 4, 5, 6, 7, 8, 9. You should have these same 9 x values for every single trig function, at least for the way I teach it. There's more than one way to graph a trig function, by the way, folks. I'm just giving you, to me, the simplest way. So here's all of our x values. Now, what was step 2? Step 2 was to determine the y values. So you're going to plug those y values into the trig function. In this case, we're using tangent of x, so we're going to be plugging those same x values that we used for sine to plug in for tangent. We're going to need to know the unit circle. So for example, what is tangent of negative pi? Well, if you look over here, it's x over y. Y over x, which is 0 over negative 1. Therefore, you're going to get y. Now, as a decimal, you don't really need the y decimal chart for tangent because you're not going to get any decimals back if you use these x values. But just to reiterate, for most of them, right, except for tangent and cotangent, you need to convert those y values to decimals for step 3 right here. So I'll just even write step 3 here, even though we're not really going to be using it. Okay, so tangent of negative pi is 0. Let's move on to the next x value, tangent of negative 3 pi over 4. Negative 3 pi over 4 is right here, and again, that's because if we go back to our little chart I made right here, negative 3 pi over 4, moving pi over 4 to the right of negative pi, is going to land right here, which is exactly the same as 5 pi over 4 in our unit circle. So tangent is y over x, and voila, you're dividing something by itself. So therefore, the answer is 1, which is what we're going to put for tangent of negative 3 pi over 4. Now at negative pi over 2, which is the same as 3 pi over 2, we have y over x. We're dividing by 0, therefore it's undefined. We'll get to how to graph that in just a second. Tangent of negative pi over 4 is negative 1, and that's because, we're taking this y value and dividing by the x value, so we're going to get negative 1. Again, negative pi over 4 is the same as 7 pi over 4. Tangent of 0 is 0. Tangent of pi over 4 is going to be, didn't mean to do that. Tangent of pi over 4 is 1, y over x. If we get back to y here, we have y over x. We're going to get undefined. And then tangent of 3 pi over 4 is negative 1. Moving full circle back to pi, tangent of pi is 0 over negative 1, which is 0. So that fills in our remaining y values for the first and second quadrants. So really, again, you only see 3 different forms of a y value, 0, 1, undefined, or some negative version of 1. It's very simple, folks, and now we're going to take these points and graph them. So the question in your mind might be, what about this undefined? We're going to talk about that in just a second. Step 4, plot each point on the graph. I like to change these to make them different colors. So we can't plot undefineds, but we can plot the rest of these. So for example, negative pi comma 0, it's going to go right here. Negative 3 pi over 4 comma 1 is going to go right here. And you can put the pieces together and see how to plot the rest of these except for the undefineds. So the rest of them scatter like this. Now obviously, I have no clue how to connect these dots, right? They're all over the place. That's why we're going to do step 5. Remember, we mentioned this before. You're going to draw vertical asymptotes for each undefined y value. So for example, if we look at negative pi over 2 comma undefined, right, we can't plot that as a point, but what we can do is plot an asymptote right there. We know there's going to be an asymptote because when we plug it in, we're plugging in 1 over 0, which is infinity. It's not going to be a whole, it's going to be an asymptote. We've talked about that before when we graphed rational functions. So at negative pi over 2, we're going to put an asymptote, and we're also going to put 1 at pi over 2. Since it's also undefined there, we're going to put an asymptote there as well. So now we can start to see a little bit better what this graph is going to look like after doing step 5 of drawing vertical asymptotes for undefined y values. Now it's still a little unclear because I mean we don't know, it might just, well actually it's actually pretty clear, folks, because it's not going to be a straight line, otherwise it would go through that asymptote, and that's not going to happen. Same thing for over here. So we know it's going to curve, and we know it's going to, an asymptote forms the curve of the graph. So as you can see, the only way to really do it is kind of make an S-curve that curves around these asymptotes. Same for over here. Okay, there's actually more asymptotes over here, but we're only graphing from negative pi to pi. But you can see that it's going to curve the same way. They're S-curves. So therefore, for step 6, when we connect the dots with the curve of best fit, we're going to draw a curve, 3 curves to be exact, that curve around these asymptotes. And these are called tan lines. And they're called tan lines because they have a distinct shape. It's kind of like a narrow S shape. Step 7 is to draw arrows to the left and right of the graph to illustrate infinity. So for tangent, cosecant, secant, and cotangent, they will have arrows and they will look like this. And we're going to go ahead and practice that right now. For step 7, let's go ahead and do that one more time. In fact, we don't really need to do this, but if I were you, I would do something like this. Draw an arrow. It's not very hard. In fact, I'm terrible at drawing, but I can at least make a sketch of a tangent graph. And that's it, folks. Those are the 7 simple steps for graphing these tangent curves. If you have any other questions about this example, let me know.